Let's review lectures and some important topics in vector space. Let's look at point one. Now, point one is what is a vector space. What is a vector space? Let's define that. Now, a vector space is an environment which could be a set of vectors that undergo scalar multiplication and vector addition. That is what a vector space is. And there are some conditions that we need to look at. Yes. Okay, let's look at the first one now. Let phi be a non-empty set closed on the vector addition and scalar multiplication. So like I said earlier, there's some conditions it needs to satisfy. And those conditions are 10 in numbers, like we have already learned in the lecture classes. So let's look at the first one now. So the first one is for every u comma v which belongs to v, that is, it belongs to vector space, u plus v will also be found in the vector space. So it is called the closure property. So that's the very first one. So let's look at the second one right now. The second one says for every u comma v that is found in v, u plus v is equal to v plus u, which is also in v. Now this is known as the commutative property of vector addition, since we are adding two vectors. So this is the second property. Now let's go and look at the third one. Now the third one is for every u, that is for every vector u, comma v, comma w, which is in the vector space v, it implies that u plus v plus w is also equals to u plus v plus w in brackets. So that is u plus v in brackets, and then on the other side we have v plus w in brackets. So now this is our associative law of vector addition, where when you open the bracket of both sides, they still give you the same set of addition of the vectors. So the right side is equal to the left hand side. So this is under vector addition. So we've treated three properties of vector addition. So let's go into the fourth one right now. Let's go into the fourth one. So the fourth one is we have for every u in v, there exists also a special vector called the zero vector, which is also in v, in which u plus 0 is equals to 0 plus u, which is equals to u. And now this is also called the additive property of also vector addition. Now the fifth one says for every u that is in v, that is belonging to v, there exists the inverse of u, that is the inverse, the negative value of u, which is also in v, in a way that when you add u plus its negative inverse, it's going to give you a zero vector, which is also in the vector space v. Now this is the additive inverse. What we mean by the additive inverse is when u, the additive inverse of u is minus u, so the addition will give rise to a zero vector. Now let's proceed. Now we have for the fifth one, we have for every u that is in v and a comma b that is in k, we have this one is quite special now because this is actual scalar multiplication. Now in this scalar multiplication, the very first property we are seeing here is a, which is a scalar, multiplied by b, which is a scalar, with u, that is bu in brackets. So that is a in bracket bu is equals to ab in bracket U. Now this is an associative, but this time around it's associative with scalar. So this associative of scalar multiplication, where two scalars are in multiplication with a vector. Now the seventh one has the addition of two scalars in brackets. U is equals to AU plus BU. Now this is known as the distributive property of scalar multiplication. It is the distributive property of scalar multiplication, where there are two scalars. Now the eighth one has two vectors, U plus V in brackets, multiplied by a single scalar, A, which gives us AU plus AV, also distributive, but this time for vector addition. Now the ninth one we have, for every U that is in V, there exists 1 in V in such a way that U dot 1 is equals to 1 dot U. So now this is the multiplicative property and could also be called the identity property, where this vector, when multiplied with other vectors, returns the vector itself. Now the 10th one, which is the very last one we're looking at, is for every U that is in the V, there exists the inverse of U, that is U raised to the minus 1, or could better be written as 1 over U, is such that U dot 1 over U is equals to 1 over U dot U, which is equals to 1. And it's also a multiplicative inverse that gives rise to an identity element. So these are the 10 properties, the conditions that need to be satisfied when considering a vector space. So in our next episode, we will consider some of the examples of vector space. Vector space can exist in different forms, and we'll also be looking at how to prove vector spaces given the following 10 conditions that I've listed in today's episode.